Good day to all. In this video, we will be seeing about what is sampling, sampling techniques, and types. Now, let us get into the video. First, let us see a brief overview of what is sampling. Sampling is a critical process in research that involves selecting a subset of individuals, units, or items from a larger population to draw conclusions and make inferences about the population. Since studying the entire population is often impractical, sampling provides a feasible, time efficient, and cost effective method to collect data and analyze trends. Sampling is the process of selecting a portion of the population to represent the entire group. The objective is to obtain information about the population by studying a representative group, ensuring that the findings can be generalized to the larger population. Now, you can ask, what do you mean by population? It is the entire group from which a sample is drawn. So next, what is sample? A subset of the population selected for study. Next comes sampling frame, a list of all elements in the population from which the sample is selected. Next, we'll see about the purpose of sampling in research. First is generalization, to make valid inferences about the population. It refers to the ability to apply the results obtained from a sample to the entire population. It ensures that the insights gained from analyzing a subset of the population can be extended to the larger group with a reasonable degree of accuracy. The importance of generalization is crucial for making informed decisions and developing policies based on research findings. It enables researchers to predict trends and behaviors across the population. This can be achieved by the use of probability sampling methods such as simple random sampling or stratified sampling. An example for this is a market research firm conducts a survey with 1,000 respondents to assess consumer preferences for a new smartphone. If the sample is selected randomly and is diverse, the findings can be generalized to predict the preferences of the entire population of potential buyers. But there are few challenges. This generalization may affect if the sample is biased or unrepresentative. Larger sample sizes are often required to improve the reliability of the generalization. Next, we have accuracy. Accuracy refers to the degree to which the results obtained from the sample reflect the true characteristics of the population. An accurate sample minimizes errors and provides a realistic representation of the population. This ensures that research findings are trustworthy and valid. It also minimizes the risk of sampling errors and bias. This can be achieved by careful selection of sampling techniques, especially probability sampling, ensuring that the sample size is adequate to reduce margin of error, avoiding selection bias and ensuring randomness in sample selection. An example for this is in a clinical trial for a new drug, a random sample of patients is selected to test its effectiveness. Accuracy is ensured by including patients from different age groups, genders, and medical backgrounds, thereby reducing bias and ensuring reliable results. The third one is efficiency, that is, to reduce the cost and time required for research. It refers to achieving maximum results with minimum resources, time, and effort. Sampling enables researchers to study a manageable portion of the population, saving both time and money. The importance of this is it reduces the cost of collecting and analyzing data, enables researchers to focus on a smaller group while ensuring meaningful results, makes large-scale research feasible by minimizing resource requirements. It can be done through systematic sampling and cluster sampling to cover large populations efficiently. Application of multi-stage sampling to break down complex populations into manageable units. For example, a company wants to assess employee satisfaction across 100 branches nationwide. Instead of surveying all 10,000 employees, the company selects a sample of 1,000 employees from various branches, reducing costs and completing the survey in a shorter time frame. But a challenge for this is an overly small sample size may reduce the validity of the findings. Efficiency gains should not compromise the representativeness of the sample. Then comes feasibility. To study large populations without examining every element. It refers to the practicality and ability to conduct research effectively within the given constraints of time, resources, and effort. Sampling makes it possible to study large populations by examining a smaller, manageable portion. Sampling makes research possible even when studying the entire population is impractical. It enables researchers to obtain valuable insights without overwhelming time and resource constraints. This can be done through use of cluster sampling or multi-stage sampling to break down large populations into smaller, manageable segments, ensuring that the selected sample is representative to maximize the relevance of the findings. Say, for example, a government agency conducts a census to collect demographic data from a nation of 1.3 billion people. Since surveying the entire population is impractical, the agency uses a well-structured sampling technique to analyze the data from a smaller representative sample. The difficulties lies in ensuring that the sample truly reflects the diversity of the population. Inadequate sampling may lead to skewed or incomplete results. Next, we'll see some basic concepts in sampling. In research, understanding the concepts of population, sample, sampling frame, and sampling unit is crucial for designing effective studies and ensuring reliable results. Each of these concepts plays a unique role in data collection, process, and impacts the validity and reliability of the research findings. Now, first, let us see about population versus sample. So, a population is the complete set of all individuals, items, or elements that possess the characteristics of interest for a particular study. It is the larger group from which the researcher aims to draw conclusions. The characteristics of a population can be defined as it can be finite or infinite, may include people, objects, events, or any unit of analysis. Serves as the source from which a sample is drawn. Some of the examples of population are all registered voters in a country for an election study, all smartphone users in a city for a product satisfaction survey, all patients diagnosed with diabetes in a hospital for a clinical trial. Now we'll go to the sample. So a sample is a smaller, carefully selected subset of the population that is used for analysis to make inferences about the entire population. Since studying the entire population is often impractical due to cost and time constraints, researchers select a sample to represent the population. A sample should be representative of the population to ensure accuracy. Sample size affects the accuracy and reliability of the results. The selection process may involve random or non-random techniques. So examples of a sample are 1,000 voters randomly selected from a population of 10 million for a political opinion survey. 500 smartphone users from a city surveyed about product preferences. 200 diabetic patients selected for a clinical trial from a larger group of 10,000 patients. Now, let us see some of the key differences between population and sample. With regard to definition, population means the entire group of interest, and sample means subset selected from that population. In regard to size, Population is large, often infinite, but sample is smaller and manageable. With purpose to provide a complete data set, but in sample to draw inferences about population. In regard to data collection, for population, it is time consuming and costly, but for sample, it is cost effective and feasible. Next, let us go and see sampling frame and sampling unit. So first we'll see about sampling frame. A sampling frame is a complete list of all elements or units in the population from which a sample is drawn. It serves as the source material or device used to identify the target population for sampling. Sampling frame ensures that every element of the population has a chance of being included in the sample. It helps in minimizing errors by providing a well-defined list of eligible units. Enables researchers to apply appropriate sampling techniques, especially in probability sampling. Examples of sampling frames are a list of all registered voters in a district for conducting an election survey, a database of customer email addresses for sending a product feedback questionnaire, a list of students enrolled in a university for selecting participants in a research project. Now let us see the key considerations in developing a sampling frame. Completeness. The list should include all elements in the target population. It should be free from duplication and errors to ensure accuracy. It should align with the objectives of the study so that it is relevant. Now let us see the challenges while setting sampling frames. If some elements of the population are missing from the frame, the results may be biased and incomplete. An old or obsolete sampling frame may not reflect current conditions. Next, we'll see about sampling unit. Sampling unit is the individual element or group of elements in the population that is selected for data collection and analysis. It is the unit at which measurements or observations are made during the research process. There are two types of sampling units. First is individual units. Single entities such as individuals, households, or companies. Second one is aggregate units, group of elements such as neighborhoods, schools, or regions. Some of the examples of sampling units are, for individual units, each voter in a voting survey, each student in a study measuring academic performance. Examples for aggregate units are households in a city for a survey on electricity consumption, schools selected to study the impact of an education policy. Why is sampling unit important? Because it defines the level at which data is collected and analyzed. It ensures consistency in data collection and it helps in determining the sampling method to be used. Now let us see some of the differences between sampling frame and sampling unit. Sampling frame means complete list of elements in population. Sampling unit means individual element or group selected. Purpose of sampling frame is to provide basis for drawing a sample. For sampling unit, the purpose is unit for data collection. Examples for sampling frame are voter list, customer database. For sampling units, individual voters and households. Relation to sample. Sampling frame defines population for sampling. Sampling unit represents elements included in sample. Errors, impact. For sampling frame, incomplete frame leads to bias. In sampling unit, improper unit selection affects accuracy. Next, we shall see about the sampling types. First one is probability sampling. Probability sampling every member of the population has a known non-zero chance of being selected. This technique ensures that the sample is the representative of the population, reducing the risk of bias. The key characteristics of probability sampling are randomness and equal selection chances. Importance for generalization. Probability sampling enables researchers to generalize findings to the broader population with confidence. Now, let us see various classifications of sampling in probability sampling. The first one is simple random sampling. In simple random sampling, each element in the population has an equal and independent chance of being selected. Use of random number generators, lottery systems, or computer-generated techniques are some of the methods used in simple random sampling. For example, to select 50 students from a university with 1,000 students, each student is assigned a number and 50 numbers are randomly drawn. So advantages of simple random sampling is it minimizes selection bias and it is easy to implement with small populations. The disadvantages are it is not feasible for large populations and it may not ensure diversity in the sample. Next, we can see about the systematic sampling. In systematic sampling, elements are selected at regular intervals from an ordered list. Systematic sampling involves selecting every nth number drawn from a random starting point within the population. So the process begins by determining a fixed interval, ensuring an evenly distributed sample selection through the population. This method excels in scenarios like quality control and field surveys, ensuring efficient data collection. For example, to survey 500 households from a list of 5,000, the researcher selects every 10th household after a random starting point. The advantages to this method is it is easy to apply and suitable for large populations. One of its limitations is it may introduce bias if the population has a hidden pattern. The next method we are going to see is stratified sampling. In stratified sampling, the population is divided into homogeneous subgroups, that is strata, based on specific characteristics, and samples are drawn proportionally from each stratum. When to use stratified sampling? It is appropriate for heterogeneous populations where subgroups vary significantly, ensuring representation of each characteristic. This method reduces sampling variability by focusing on specific characteristics, enhancing the overall precision of estimates. The advantages to this method is it ensures representation of all subgroups, it reduces variability between strata, but the limitations include it is being complex and time consuming and it requires detailed information about the population. An example for this type of method is a researcher divides for employees into 3 strata based on department and randomly selects employees from each department. The next method we are going to see is cluster sampling. In cluster sampling, the population is divided into clusters and entire clusters are randomly selected for a study. This divides the population into clusters, example, regions or groups, and select clusters randomly for inclusion. This method is cost effective and efficient. It is useful for geographically dispersed populations. But the disadvantages are it has higher chances of sampling error and clusters may not be homogeneous. Say for example, to study healthcare facilities, a researcher divides the country into districts and randomly selects 10 districts to study. This gives rise to sample error risk. Potential for increased sample error arises due to within cluster similarities affecting the representativeness of the findings. Next, we shall see about the non-probability sampling. Non-probability sampling means not all elements of the population have a chance of being included in the sample. It is often used when probability sampling is impractical or when the focus is on qualitative insights. The methods include convenience, judgment, and quota sampling, diverging from random mechanisms in probability sampling. Research validity diminishes as non-probability sampling can introduce bias, limiting generalization of outcomes. Now we'll see them one by one. First is convenience sampling. In convenience sampling, elements are selected based on their availability and willingness to participate. Convenience sampling selects participants based on easy accessibility, often resulting in non-representative samples. Strengths of convenience sampling are this method often offers ease of access and quick data collection, ideal for preliminary studies and low-cost research. But the weaknesses of this method is susceptibility to selection bias, compromising the validity and generalization of the findings. For example, a researcher surveys students at a nearby mall because it is convenient and accessible. Next, we shall go to purposive or judgmental sampling. In purposive sampling, participants are selected based on the researcher's judgment about who will provide the most relevant information. It targets specific individuals to gain in-depth insights pertinent to qualitative research. This sampling method is ideal for exploratory studies focusing on unique perspectives or specialized populations. For example, a researcher studying entrepreneurship selects successful business owners to gain insight. The advantages of this method is it is useful for in-depth qualitative research and it focuses on specified characteristics. But the disadvantages are it has a high risk of researcher bias and it has limited generalization. The next one is snowball sampling. In snowball sampling, existing participants recruit future participants from their acquaintances. Snowball sampling identifies initial subjects who then recruit additional participants through their social networks. This method facilitates access to hard-to-reach populations, enhancing participant diversity and expanding sample size. But the drawbacks of this method is that potential biases arise as participants may refer similar individuals, limiting diversity and representativeness in findings. An example of this is a researcher studying a rare medical condition uses initial participants to refer others with the same condition. Next, we'll see about quota sampling. Quota sampling means the researcher ensures that the sample reflects certain characteristics of the population. It involves selecting a predetermined number of individuals from various subgroups within a population. The process includes identifying key characteristics, setting quotas for each group, and selecting participants accordingly. The advantages of this is it includes representation of key characteristics, but the disadvantages means potential biases affecting the sample's overall validity. An example is to survey 200 people with an equal number of men and women. The researcher stops selecting participants once the quota is met. Thank you for listening to the class.